So I'm going to deal with vectors now. Vectors has got x-axis, y-axis and z-axis, which can be represented as I cap, a j cap and a k cap. Okay, this is what is representation of directions, and I, j and k are just unit vectors whose magnitude is just 1. All that we can say is that that's got a direction. This is along x-axis, along y-axis, and this is along z-axis. Supposing there's a position vector p, which is like 1 from the x-axis, a 2 from the y-axis, and a 3 from the z-axis, which is the Cartesian coordinates. You don't write it as 1 comma 2 comma 3, you will write it as 1i plus 2j plus 3k. This origin is 0i plus 0j plus 0k. And join these two vectors, you get this. If you want to find the magnitude of this, or first find the line vector. So first find the line vector. The line vector is OP vector whose formula is x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. The line vector. Supposing this is x1, y1 and z1, and this itself is x2, y2 and z2. This is 1 minus 0 into I plus 2 minus 0 into j plus 3 minus 0 into k. So thus you get a line vector. This is called a line vector or p vector, which is p minus o, x2 minus x1. Okay, then find the magnitude of this vector. Its root of the component has to be squared. 1 square plus 2 square plus 3 square. When you square these components, you get root 14. This shows that this vector is definitely not a unit vector, because unit vector is one whose magnitude is unity. Unity means 1. So how to convert this vector into unit vector is take that vector and divide it by its magnitude. So take the vector and divide it by its magnitude. So 1 by root 14 into I plus 2 by root 14 into j plus 3 by root 14 into k will give me my unit vector. Obviously the magnitude of this, just square it. 1 by 14 plus 4 by 14 plus 9 by 14 will become 14 by 14 and will become 1. So it makes sense to call it as a unit vector. Now, this is nothing but cos alpha. This can be written as cos alpha into I plus this can be written as cos beta into j plus cos gamma into k. Hence they can be called as direction cosines, DCs. In a unit vector, the coefficients are called direction cosines. In an ordinary vector, they are called direction ratios, DRs. So these are DRs and these are DCs. So the vector can also be cos alpha into I plus cos beta into j plus cos gamma into k. Therefore, the magnitude of this vector cos square alpha plus cos square beta plus cos square gamma is also equal to 1. Squaring both sides, you get cos square alpha plus cos square beta plus cos square gamma is equal to 1. You can write this as 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma, which itself will be equal to 1. So then you can therefore take 1 plus 1 plus 1 to be 3 minus of sin square alpha plus sin square beta plus sin square gamma itself is 1. Therefore, a sin square alpha plus sin square beta plus sin square gamma itself will get you a 2 as the answer. So these are something you need to learn. Next time, what I taught you is about a dot product. An A vector dot B vector is magnitude of A into magnitude of B into cos theta. Means they ask you angle between the two vectors. Cos theta is A vector dot B vector by magnitude of A into magnitude of B. How to dot it? You know that supposing A vector is 1i plus 2j plus 3k and a B vector is 2i plus 3j plus 4k, say for example, we're going to dot A dot B. It's 1i plus 2j plus 3k is going to be dotted with a 2i plus 3j plus 4k. While dotting, you can only dot an I and an I, j and a j, a k and a k, because the angle between I and I is what is 0 and a cos 0 is 1. You can never do I and a j because angle between them is 90. Cos 90 will become 0. So therefore, dot I and I 2. 1 2s are 2, 3 2s are 6, 4 3s are 12. I square, j square, k square all 1 whose magnitudes are all unities. So then therefore the answer is 20. It's a scalar. It results in a scalar, not a vector. That's why a dot product is also known as a scalar product. Okay, so let's talk about a cross product. A cross product is one in which you're going to do A cross B, which is magnitude of A into magnitude of B into sine theta into n cap, because a cross product is a vector product. The answer will still remain to be a vector. So I'll just tell you how to cross it. I, j, k, and I cross j is k, a j cross k is I, a k cross I is j. If supposing the direction is getting interchanged, I cross k will be minus j. You have to insert a negative sign. So let us cross an A vector and a B vector. A vector is 1i plus 2j plus 3k. You're going to cross it with a 2i plus 3j plus 4k, which is a b vector. You can only cross an I and a j, I and a k, j and I, j and a k and I, k and a j. So it gets really complicated. The easier way to do, actually, I'll just show you one example. I, j, k. You're going to do one with a j. That's what you can do because sine theta is there, sine 90. So therefore, I and a j, I and a k. So 1 3 is a 3 into I cross j. What is I cross j? Is k. So 3k. Then 1 with a I with a k, which is 1 4 of 4 into I cross k. What is I cross k? It's in this direction. So it's minus j. So 3k minus 4j. Like that, the answer will go on. It's very difficult to do it this method. Get to know this method, but I'll teach you a shortcut. The shortcut is to put in determinants. Write it as I, j, k. Write these numbers in here, which is 1, 2, 3, and 2, 3, 4, with a positive, negative, and a positive. And so you write I into and a minus j into plus a k into and close. When you take I into, make sure you remove that row and that column. And the rest of it, your top to bottom is 4 to 8 minus bottom to top is 3 3s are 9, 8 minus 9, which is minus 1i. Minus j, you have to omit that row and that column. Do top to bottom minus bottom to top, which is 4 minus 6, which is minus 2 plus 2j. When you ring plus k into, which is plus k is here, you omit that row, that column, top to bottom minus bottom to top is 3 minus 4. So therefore it's minus 1k. Thus you resulted in a vector. That is why a cross product is called vector product. Make sure writing positive, negative and positive and then proceed. So thus you get a vector product. A cross product always results in a vector. Okay, from this also you can of course find sine theta. Sine theta is a vector cross b vector by magnitude of a into magnitude of b. The whole magnitude because it's still a vector. Okay, so whole magnitude. But coming back to, let's go to parallel vectors. Supposing there's an a vector which is parallel to b vector, the condition for parallel vectors is a vector is lambda times b vector. Or in other words, a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to some constant. So what is the meaning of it? Supposing a vector is 1i plus 2j plus 3k, the b vector can be a scalar lambda times a scalar maybe 5, 6, whatever. 6 means 6i plus 12j plus 18k. To find out if this parallel, you do a1 by a2 is equal to b1 by b2 is equal to c1 by c2. You still get 1 by 6 and the lambda is 1 by 6, which shows that they are parallel. So for supposing you want to talk about perpendicular vectors, an a vector is perpendicular to b vector provided a vector dot b vector is equal to 0. Okay, if because dot product has got cos theta, cos 90 will come, no, perpendicular, a dot b is 0. Or in other words, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. These are the conditions for perpendicular vectors. So next is projection. Supposing you want to project a vector on b vector, on b vector, so it's a vector into b cap. And how did I get this formula? Supposing in physics you have something like this. You write as theta and write the horizontal component, which is a cos theta. The vertical component will be a sin theta. The projection along b vector is magnitude of a into cos theta. A cos theta in itself is a vector dot b vector by magnitude of a into magnitude of b. So this and this get cancelled. A vector into b cap is your answer. So that's how you get this. So this is about how to project a vector in other vectors direction. So next is supposing you have two vectors a and b. You want to get a vector perpendicular to both a and b, which is mutually perpendicular to both a and b. That's a c vector. You just have to cross these two vectors. You cross a vector and b vector, you automatically will get a vector which is perpendicular to both a and b. This is what I call it as scissors. Scissors, because this is like a scissor. Can you see from here? This is like a scissor. I'm crossing these two to get a vector perpendicular to both a and b, and you know how to cross it. So this is very, very important to get a vector perpendicular to other vectors. Okay. Next is I'll teach you triangle law. In triangle law, so what is triangle law? You have an a vector like this, you have a b vector like this. The third vector in the opposite direction is called the resultant, which is the sum of the other two vectors a plus b. Resultant or sum means the same. Okay, suppose another triangle law where this a vector and this b vector and c vector, all of them are in the same direction. You can say a vector plus b vector plus c vector itself will become 0. There's no displacement. It comes back to the same point. So these are the two triangle laws. Okay. Next is I'll teach you parallelogram law. Parallelogram law. Supposing you have an A vector here and you have a B vector here. But you have to draw it only like this. The B vector can be constructed parallel to this B vector, which will not be lambda times. It will still be B because the opposite sides of parallelogram. Lambda is just unity 1. You construct a diagonal, which is the resultant, which is A plus B by triangle law. But I don't want to use triangle law because I'm teaching you parallelogram law. Construct this into a right triangle. Supposing theta is the angle between A and B vectors, this is just a projection of A vector, and so this will also be theta. Therefore, the adjacent side can be written as B cos theta, and the opposite side can be written as B sin theta. So then you take the full triangle now, you can find the resultant, which is root of base square, which is A plus B cos theta the whole square, plus the height square, which is B square sin square theta. So let's expand this. It's A square plus B square cos square theta plus 2AB into cos theta plus B square sin square theta. You consolidate these two. You get the resultant to be root of A square plus B square plus 2AB cos theta. Why? Because B square common sin square theta plus cos square theta will just add up to 1. So this is the formula with a plus symbol for the resultant through parallelogram law. Okay, you must be clear till here. Then is about you can play it again and again. This supposing this angle is beta, the direction that the resultant makes with the first vector, you can write tan beta to be b sin theta by a plus b cos theta opposite by adjacent merely. Okay, so that's about the parallelogram law. And next is about law of sine. Law of sine. The law of sine is like you have a triangle where you have A, B, and C. This is angle A, angle B, and angle C. Opposite to angle A is a small side A, small angle A, side A, sorry. Or the opposite to B is B, and opposite to angle C is a small c. These are the sides. The law of sine means this side A by the sine A is equal to B by sine B is equal to C by sine C, and how to prove that? To prove that, you have to construct a perpendicular n. You can do sine B from this triangle and sine C from this triangle where its opposite, which is an, by hypotenuse, which is c for this triangle, and sine C, which is opposite, which is an by hypotenuse b. So we can write what is an for both these equations, c sine b, and an from this equation is b sine c, and both of them are equal. C sine B is equal to B sine C. You can bring the sine C down. So you get C by sine C is equal to B by sine B. We got one part of the equation. Take the same triangle, do an altitude. This is A, B, and C. You draw this as small a, small b, and small c. Draw an altitude n like this. Take this triangle and this triangle. Write what is sine A from this triangle, which is height bn by hypotenuse c. Write sine c from the lower triangle, which is bn by the hypotenuse a. The bn here is c sine a. The bn here is a sine c. You can equate both of this because both of them represents bn. C by, therefore C by the sine c will come is equal to a by sine a. This is my equation 2. Can you see C sine c is here, C sine c here is here. So equating 1 and 2, you get a by sine a is equal to b by sine b is equal to c by sine c, and that confirms the law of sine. So let's go to law of cosine. The law of cosine. What is law of cosine? Is this when you know two sides, say you know side A and side B, and you know the angle between them is C. You can find the third side, which is a c, small c, which is root of this square plus this side square minus 2ab and a cos c, and you need to memorize this angle c. This is what it is if you know two sides, and we're going to prove this. Similarly, you can write a is equal to the other two sides b square plus c square minus 2bc cos a, and similarly b is equal to root of a square plus c square minus 2ac cos b, and these are called law of cosine and how to prove law of cosine. So let's draw a triangle like this, with this being a, b, and c, and as usual draw a normal here. Okay, and in this it's a law of cosine is called cos is the base. So then therefore take this, this is small a, this whole thing is small b, and this whole thing is small c, and this is angle A, angle B, and angle C. Okay, you take this and write what is cos B. Adjacent BN by hypotenuse. Therefore, BN itself is C cos B. Substitute it here. C cos B is this side. Therefore, this side will be A minus C cos B. A minus C cos B, where C is a small c cos B. Because this minus this length will give you NC. You already know what is AN by using sine B. Sine B is equal to opposite by C. So, opposite itself is C sine B. Now, you got a right triangle. That's all. You can find B, the opposite side. Pythagoras theorem, we're going to use this triangle and use Pythagoras theorem where B itself is root of base square, which is A minus C cos B the whole square, plus height, which is C square sin square B. Expand it. B itself is root of A square plus C square cos square B minus 2AC cos B plus C square sin square B. From this and this you have C square, which is common. So you get A square plus C square minus 2AC cos B, which is nothing but your law of cosine. Very, very simple. So therefore, by constructing like this and using a right triangle, you can find law of cosine. One of it is what I found. Similarly, you can find A and C's, but finding one is good enough. This is what I had taught you today. Make sure that you're so clear, okay?